This is Algebra 2, test number 8 study guide. We got through 5.2, which was factoring to solve quadratic equations. We are factoring this first set of problems. We have x squared plus 14x plus 48. This is a trinomial because there's 1, 2, 3 terms up there. What you want to do, you want to make two sets of parentheses underneath it. Remember, this is ax squared, a's value is 1, plus bx plus c. You want to factor out c's factors. What that means is 1 times 48, 2 times 24, 1 times 48, not 42, 2 times 24, 3 times 16. Notice as our numbers on the left are getting bigger, our numbers on the right are getting smaller. Eventually, those numbers are going to get right next to each other as close as possible. 4 is going to multiply times 12. And 6 is going to multiply times 8. Notice how close the numbers 6 and 8 are to each other. That's how you know there's no other numbers that multiply by the number 48. So we know that x times x is going to give us x squared. What we are doing when we're factoring is we're doing the reverse of FOILing. FOIL means first, then outer, then inner, then last. We're undoing, or we're doing the reverse of it. So our values of c, the pairs of c that are going to get us to our b value, which is 14. That's what we're looking for. This pair here, 1 and 48, is either going to get you to 47 or 49. Don't think in terms of positives and negatives right now. Don't think in terms of addition or subtraction. Just combine the numbers. 47, 49. That's not 14, so that's not it. 2 and 24 is either going to give you 22 or 26. That's not 14. 3 and 16 is either going to give you 13, we almost there, or 19. Still, though, not 14. 14 and 12 is either going to give you 16 or it's going to give you 8. Again, not 14. The only pair that's going to give you the number 14 is 6 and 8 because together they're either going to give you 14 or 2. So we're going to have to use the numbers 6 and 8. Again, notice I didn't put any additions or subtractions or any signs in there. Once you have x and 6 and x and 8, you can go ahead and discover or you can decide what the signs are. The sign in front of C is plus. That means the same sign. That's what that tells you. All that one tells you is either they're the same or different. That tells you they're the same. Since they're both the same, this sign right here tells you they're both plus. And this is the factored version. X plus 6 times x plus 8. We're going to do the same thing for the next one. Notice how much fewer factors there are in the C value this time. 8. We're going to make two sets of parentheses. This is ax squared plus bx plus c still. Your c values, which is 8, 1 times 8 and 2 times 4. That's the only ones you have to fool with right now. You're still going to put x times x to get x squared. And then you're looking for your factors, your pairs that are going to get you to the number 6. 1 and 8 is either going to get you 7 or 9. That's it. So 2 and 4 is the ones you have to use. 2 and 4. Again, notice we have x and 2 and x and 4. Now look at your signs. This one tells you the same. This one tells you they're both what? Negative. Minus 2, minus 4. Easiest way to factor is just like that. There's a lot of other different ways people try to do it. This is the simplest way for most people to understand. Number 3 says x squared minus 2x minus 63. Here's one right here where we're going to have different signs. Okay, x times x gives you x squared. There's a lot of factors of 63. Let's not list all of them out this time since we're trying to get to b's value of 2. That means we need two numbers that are right next to each other. We can do 1 and 63 and all that stuff, but again, it's not necessary. We can do 3 and 21, but 3 and 21 are not going to give you the number 2. The only ones that's going to give you the number 2 when you're doing 6 and when you're doing your factors of 63, like 1 times 63, that's either going to give you 64 or 62. Your numbers 9 and 7 are going to give you the numbers to get to 2. So 9 times 7 is 63. Again, if you have to list all the factors out, it's okay. Do that. I'm just trying to speed this along a little bit. 9 and 7, okay? Now your sign in front of C this time, unlike number 1 and 2, now it's negative. This tells you they're not the same anymore. Now it tells you they're different signs. Since they're different, you look at the sign in front of B. That is the one of the bigger absolute value. 9 is a bigger absolute value than 7, so it's negative. They're different, so this one is positive. x minus 9 times x plus 7. Okay, here's a version where A's value is not 1. Okay, so this is the first one on the study guide where A's value wasn't 1. This is where you have to do a little bit of trial and error with this. Fortunately, there's only one pair of factors for the number 5. So when we make our sets of parentheses, one of them has to be 5x and the other one has to be x. Where this really comes in and where it really becomes a problem is when there's more than one pair of factors for that A value. There's only one right here, so it's not going to cause us way too much problems. Also, we know for our values of C, there's not a lot of factors of the number 15. We know we got 1 and 15, and we got 3 and 5. Those are the only ones. So we're going to have to try 2 different versions of each of those numbers. Okay. Again, when you FOIL this, you're trying to get back to your B value of 22. You're trying to get back to that number, and more specifically in this case, you're trying to get to negative 22. So when you multiply, if we were to put right here 15, when we multiply that times 5, we're going to get a number that's way too big to get back to 22. So right away, if we try to use 15 and 1 in that way, it's not going to work. So instead of going and working the whole thing out, it's not necessary. Maybe we can try it the other way. 15 right here and 1 right here. When we FOIL that, we're going to get 5x and we're going to get 15x, which is going to give us 20x. That's not 22. So we can't use any version of 1 and 15. We have to use some version of 3 and 5. So this one right here, and again, this is the most tedious version. I told y'all I wasn't going to give y'all a whole lot of examples of having a bunch of A values except 1. We're going to have to use some version of 3 and 5. So we either want to put 3 in the first set of parentheses or 3 in the second one. We're trying to get to the number 22. If we put 3 here, 5 times 3 is going to give us 15. If we put 5 here, 5 times 1 is going to give us 20 again. So that's not what we're going to use. So we're going to have to go about the last trial and error method, and we're going to have to put our 3 here first and our 5 here. Now let's look and see what we got. When we unfoil this, now go back what I told you to do about with the signs. This sign right here says that they're different signs. This one tells you the larger number is negative. So 5 is larger, so it's going to be negative. 3 is smaller, it's going to be positive. When you FOIL this, 5x times negative 5x, you get negative 25x. When you, that was the outer terms. When you FOIL it, the first terms, 5x times x is going to be 5x squared. That's what we're trying to get. Then your inner terms, 3 times x is plus 3x, and then your last terms, 3 times 5 is minus 15. Combining these here, negative 25x and positive 3x, you can see that you get to negative 22x, and that's what we were trying to get to. So sometimes you have to work FOIL backwards. Sometimes you have to work it forwards to where you can see what's going on. But ultimately, this is what you're going to have to come up with right here, 5x plus 3 times x minus 5. And again, I might have one problem like that on the test tomorrow, or 2 at the most. Number 5 has 9x squared minus 16. This is the difference of 2 perfect squares. This one, if you take the square root of 9, you get the number 3. If you take the square root of x squared, you get x, because x times x is x squared. If you take the square root of 16, you get the number 4. This is the difference of them. So it's 3x plus 4. This is one of those special circumstances, times 3x minus 4. Anytime you have the difference of 2 perfect squares, one of them is going to be plus, the other one's going to be minus. Other than that, all you do is take the square root of each of the numbers. Okay, solve by factoring. Again, this one's not as hard as it looks because fortunately for 4x squared, 28x, and minus 32, they all have the number 4 in common. So if we pull the number 4 out, we can multiply that times x squared to get 4x squared. We can multiply that times 7x to get 28x, and we can multiply that times negative 8 to get negative 32. So what that does, in a sense, is that eliminates that number 4, and it makes a lot smaller, easier numbers to deal with. So then you factor it out just like you did for 1, 2, 3, and 4. Make 2 sets of parentheses. We don't have a lot of factors of our C value 8 in this case, so you do x times x. Again, our C value is 8, so it's either 1 times 8 or 2 times 4. Which pair gets you to your B value of 7? The only pair up there that works, since 2 and 4 either get you to 2 or 6, the only pair that up there that works is 1 and 8. This right here, this sign, again, tells you that they're different signs. This one tells you the larger number is plus. 8 is plus, 1 is minus. So now you have x minus 1 times x plus 8. This is considered factored. But notice the difference in number 6 and the rest of them. It tells you to solve it. If you can get to the part where it's factored, the next step is extremely easy. You take one of the equations or one of the factored binomials and say x minus 1 equals 0. And you take the other one, x plus 8, again, equals 0. So you're going to come up with two answers. You can always determine that you're going to come up with two answers to a problem if the degree of the problem is squared. So right here, all you have to do is undo this minus 1 by adding 1 to both sides. X's value is 1, and subtract 8 on both sides. X's value is negative 8. So those are your two answers, 1 and negative 8. Number 7 is identifying the vertex of the graph. Remember, the vertex is either going to be the point that is the highest or the lowest point. This point right here is the vertex of that graph. Its x value, it doesn't go left or right at all, so its x value is 0. Its y value is negative 1. The vertex is 0, negative 1. Then it says, tell whether it's a minimum or a maximum. Is it at the bottom or the top? The bottom, so that would be considered a minimum. Where is the vertex? If it were a maximum, it would look like that. This is one that opens up like a U, so it's going to be a minimum. Number 8 tells you the graph, and then it says f of x equals negative 2x squared plus 2x plus 1. You treat this as if it says y, so don't freak out if you ever see a function notation like that, f of x. Y equals negative 2x squared plus 2x plus 1. First thing you need to do in order to find this is you have to find your b value. I still have it written on the board up there all the way on the right. Your, I'm sorry, not your b value, your x value is negative b over 2 times a. This is what we learned last week, and we never did test on this because we took our Algebra 1 test out by mistake. It is written in standard form, ax squared plus bx plus c. So take your b value, which is 2, it's negative, and then plug in your 2 value, over 2 times a's value is negative 2. So you have negative 2 over 2 times negative 2 is negative 4. A negative times, a negative divided by a negative is a positive. The number 2 goes into both of these, so x's value is 1/2. So here is your x value. So when you graph this equation already, graphing this equation, you know that its x value is at 1/2 right there. So halfway between 0 and 1, which means that is your axis of symmetry, just a vertical line going straight up at x's value being 1/2. So your axis of symmetry, x equals 1/2 when it tells you to label your axis of symmetry. From there, you have to find the vertex. It's either going to open up or it's going to open down. We know by looking at this equation, since its a value is negative, we're going to have something that opens down. It's going to look like that. So we're looking for the top of this graph now. In order to find y, we're going to take our x value and we're going to plug it back into the original equation. So our original equation said y equals negative 2 times x squared, I'm going to have to slide all of this over, times x squared plus 2 times x plus 1. We just found x's value a second ago for the vertex, 1/2. So here we're going to plug in 1/2 for x, and right here we're going to plug in 1/2 for x. So first things first, square 1/2. That gives you negative 2 times 1/4. plus, if you multiply 2 times 1/2, you're going to get plus 1, and then plus 1. So we have one more thing we have to deal with. We have to deal with 1/4 of -2. So what you want to do is put this over 1 and cross cancel if you can. The number 2 goes into itself 1 time, and then the 4 2 times. Multiplying straight across, -1 times 1 is -1, and 1 times 2 is 1/2. So -2 times 1/4 is -1/2. Plus 1, plus 1. So that's 2, if you put those two together, 2 minus 1/2. So your y value, to make it as easy as possible, your y value is 1.5, or 3/2. So when you graph this on your axis of symmetry, if y's value is 1 and 2, you know that this is the top of the graph, x comma y, 1.5 would be right there. There's our vertex. It's at 1/2, comma, 3/2, or 1.5. That's your vertex. Now everybody acts like the next step is the hard part, but this is when it actually gets extremely easy. We know that we're going to slide over one more time, and then we're going to slide over one more time after that. So that's as far as we have to go left and right, the marks that I have up there. Because we're not even going to slide a whole time. We're just going to slide to use x's value is 0. We'll use the y-axis going up and down. So when x's value is 0, you could have moved over to 1 and done the same thing. Plug x's value in to the original equation. Y equals -2 times 0 squared plus 2 times 0 plus 1. Anything 0 squared and anything times 0 is 0. Again, anything times 0 is 0 plus 1. Y equals that plus 1 right there. So that's why we like to use those numbers like 0, because you can easily do the arithmetic. So when x's value is 0, y's value is 1. Again, the axis of symmetry says on the other side, when you slide over that same half, it's going to be in the same spot. So now you have to decide, do I want to slide over one more time and use +2 or -1? It's probably easier to use -1, even though it's negative. It's easier to fool with the number 1 than it is to fool with the number 2, especially when you start squaring it and stuff like that. So if we slide over one more time, and we call this one right here, this value, x equals -1, we'll use that one just like we used x equals 0 a minute ago. So x equals -1, we'll plug it into the original equation. Y equals -2 times -1 squared plus 2 times -1 plus 1. Again, that looks like a tough equation, but it's really not. When you square -1, you know that that's going to be 1. And when you multiply 1 times -2, you're going to get -2. 2 times -1 is going to be -2 again, and then bring down your plus 1. So y's value equals -2 minus 2, which is -4, and -4 plus 1 is -3. So y's value is -3 when x's value is -1. So we got to move down 1, 2, 3 times on our y-axis. So when x's value is -1, our y value is going to be -3. And again, the axis of symmetry says when you slide one time that way, on the other side of it, it's going to be mirrored on that side. And you can draw your graph from the vertex going down to draw your parabola. Number 9 says a ball is thrown into the air with an upward velocity of 36 feet per second. Its height h in feet after t seconds is given by the function h equals -16 t squared plus 36t plus 6. In how many seconds does it reach its maximum height? Round to the nearest hundredth if necessary. And what is the ball's maximum height? Okay, so think about what's going on right here. A person standing here, they throw a ball in the air, it goes up, it comes back down. So what you're doing is a function of this throw right here. You're doing a function of this throw. So at 0 is where the person is. When it gets to its highest point, then the seconds are going to pass. How many seconds are going to pass? And then the height is how high is it going to be. So all we're looking for in this thing, even though it looks like it's tough, even though it looks like a lot when you read all of these words, all you're looking for is the vertex of this. If you can find the vertex, then you can answer both of these questions very, very easy. Okay? This is a lot easier than number 8 was because there's less to do. There's much less to do on this. You find the vertex the same way. Find x's value. X is still equal to negative b over 2a. So you know that this is a's value, this is b's value, and this is c's value. So negative b would be negative 36 over 2 times a. We know a's value is negative 16. So 2 times a would be negative 32 over, negative 36 over negative 32. A negative divided by a negative is going to be a positive. We know that the number 2 goes into both of these, even if you don't know if there's a number that's larger that goes into it. 4 actually goes into it for sure. So a negative divided by a negative is a positive. 9 over 8, because the number 8 goes into 32. So the x value in this case is 9 over 8, which is the same thing as a mixed number 1 and 1/8. So what this is saying is its x value, if this is 1 second and this is 2 seconds, 1 and 1/8, and let me move those real quick to where they match a little bit better. But it's going to be, if this is 1 second and 2 seconds, now it'll match a little bit better. At 1 and 1/8 is going to be your axis of symmetry. So your axis of symmetry, x's value equals 1 and 1/8, or 9 over 8. Not 1/2. 1 and 1/8, or 9 over 8. So when it says how long does it take, how many seconds, 1 and 1/8 is how many seconds it is, 1 and 1/8. When it says round to the nearest hundredth, if necessary, it's not necessary round to the nearest hundredth. 1 and 1/8. If you divide 1 by 8, I know we're starting to get really rounding on. But 1 by 8, you have to do that. It goes into it once. Minus 8 is 2. So bring down your 0. It goes into that one twice. Minus 16 is 4. It goes into that one 5. So 1.125. 1 and 1/8 is the same thing as 1.125. Most of y'all would rather use the decimal equivalents anyways. 1.125. That's how many seconds it is. So how many seconds pass by? The amount of seconds is 1.125, or when it says round to the nearest hundredth, we're only going to go one space after the decimal. We're going to make that 1.13 seconds. That's how long it takes to get to its highest point. The highest point is going to be the y value on your y-axis. So all you do is plug in 1.13 or 9 over 8 into your equation to find what your y value is. So what we're going to do is your h represents your y in this case, negative 16 times 9 over 8 squared plus 36 times 9 over 8 plus 6. That's going to give us, all of that right there is going to give us how high our y value gets, or how high that ball gets. And this is a problem that's much better calculator is used for. If you plug in 1.125, and you square it, then multiply by negative 16, and then multiply that 36 by 1.125, and add all of that together, your height or your, its highest value, its maximum height is going to be 26.25. 26.25, and it's talking about, since it says feet per second, it's talking about 26.25 feet will be its maximum height, or 26 and a quarter is the same thing as 26.25. So the two answers you need are how long does it take to get to its maximum, 1.13, since it tells you to round to the nearest hundredth, and how high does it get, 26.25